Section 1.6 is on page 73, talks about rules of inference. We start with a definition, an argument, that definition. An argument is propositional logic, is a sequence of propositions. All but the final proposition of the arguments are called premises, and the final proposition is called the conclusion. An argument is valid if the truth of all its premise implies the conclusion is true. An argument form is propositional logic, is a sequence of compound proposition involving propositional variable. An argument form is valid if no matter which particular propositional are substituted for the propositional variable in its premise, the conclusion is true if the premises are all true. So if you have multiple, so this is the remark from the definition of valid argument form, we see that the argument form with such propositions and the conclusion is Q is valid exactly when all of these implies Q is tautology. Now I'm looking at the first. This is an example from the book. Consider the following argument involving propositions, which by definition is a sequence of propositions. If you have a current password, let's call that P, password, then you could log on the network. You have a current password. Therefore, the conclusion, you can log on to the network. The way we write this, we say, if you have a current password, then you could log on to the network. And this means and you have a password. The conclusion, this means these three dots, therefore you can log on to the network. That's the conclusion. These are the sequence that they're talking about, sequence of propositions, and this is the conclusion. So there's a table in the book and it talks about all of these arguments. This table will be provided on your test. You just have to match what is what or just call it what it is. So if you look at the above argument, P and P implies Q, therefore it's Q. So this would be a modulus ponens. So you're going to have to name those on the test. I'm going to go over to page 82 and get a few things going. Now we're going to try to write these in arguments and then match what they are. Just find the argument form of the following argument and determine whether it is valid. Can we conclude that the conclusion is true if the premise is true? Well, let's see. And by the way, here you do notice that these are backwards, but this is and. So and you could switch any way you like. So here you could say P implies Q and P, that implies Q. That's still the same thing. So let's look at this argument. It says if George does not have 8 legs, let's call L for legs, does not have 8 legs, then he is not a spider. Let's call S being a spider. He is not a spider. Doesn't this mean that not L implies not S? And they say George is not a spider. George is a spider. Now, if this is not a spider, isn't that S? Therefore, George has 8 legs. Now, if you look at such propositions, when you say this and this, therefore L. If I look up there, I notice this is modulus tollens. Notice P implies Q and not Q implies not P. Assume this is L implies S and not S, therefore not L. So you could do the negation of those. That works as well. So this is modulus tollens. If I start with number 4, it reads, what rule of inference is used? So we need to write this in propositions and conclusion to really figure out, or premise and conclusion to really figure out which of the inferences in the table it matches. Again, I'm going to give you the table and a list of those. You have to tell me something like that on the test. So here it says kangaroos live in Australia, okay, and are marsupials. Therefore, kangaroos are marsupials. So if we glance and try to figure out where does it have that, something like P and Q, therefore Q. P and Q, therefore Q. Right there. That's called simplification. Now if I go for the next B, if it is neither hot, if it is either, not neither, if it is, I'm just going to shift this up a bit. If it is either hot than 100 degrees today, or the pollution is dangerous, it is less than 100 degrees outside, conclusion, therefore it's dangerous. So we're going to try and eyeball again. What does this match? I look in the table and try to figure out how this works. So I have something like up there, it's going to be P or Q, and not P implies Q. Right? Something like that. P and Q, P and Q, and not P implies not Q. Right there. P or Q and not P implies Q. That's disjunctive syllogism. So again, you're going to have to identify something like that on the exam. I think it was 2 L's. Hopefully I spelled that right. Now let's look at C. Linda is an excellent swimmer. If Linda is an excellent swimmer, then she can work as a lifeguard. So call this L, call this S. The conclusion, therefore, Linda can work as a lifeguard. Okay, what allows to do that? So S and S implies L, therefore L, or S implies L. So we're looking for P implies Q and P, therefore L. Oh, that came up already. That's the first one, isn't it? P implies Q, that is modulus Yeah, like the first one. Oh no, the first one was Tollens. Okay, this is Tollens. Okay, let's go for the next one. Next one states Steve will work at a computer company this summer. So Steve will work at a computer company this summer. Therefore, conclusion, therefore, this summer Steve will work at a computer, or he will be a beach bum. Let's call that B. So this is B, this is C. So we're looking for P, therefore implies P or Q. P, therefore, okay, right there. That's addition. Now we're going to use those later on in later chapters. I just needed to be able to identify them in this case. That's pretty much the purpose of what we're going to do right now. And the last one, it says, if I work all night on the homework, then I can answer all the exercises. If I answer all the exercises, I understand the material. Therefore, if I work all night on the homework, then I can understand the material. So H implies E, E implies M, therefore H implies M. That's transition, but what is it called here? Let's see. P implies Q, Q implies R, therefore P implies R. That's hypothetical syllogism. So you get the idea. All right. One more. Again, we just want to get acquainted with that table, and that's all we have to do here. Let's see how this goes. Number 6 is to use rules of inference to show that the hypothesis, if it does not rain, so let's call rain R. That means if it does not rain, or it is not foggy, let's call F foggy, or it is not foggy, then the sail race will be held. Let's call the sail race S. The sail race will be held, and the life-saving demonstration will go on. Let's call that L and L. Okay, so far that's what we have. Then it says, if, a new statement, if the sail race is held, then a trophy will be awarded. Call that T. And the trophy was not awarded implies the conclusion that it rained. So we want to show this. We need to set up a proof. Let's do this in 2 columns. So one column we list what we have, and the other column we list based on what. So we start off by the first. Let's see. We're given a trophy was not given. This is hypothesis. So this is the reasoning. and these are the steps. 1. Step 2, we have S implies T, that's hypothesis. 3. Now, if I have S implies T and not T, conclusion is that not S, right? That's modulus tolerance using 1 and 2. And you could look at that up there. Now, we're going to go for the second. It says not R and not F have happened, implies S or L. This is hypothesis. So more S, okay. Now, if I take the negation out, that becomes R and F implies, and if I take the negation of this, negation of R and or the negation of L, this is contrapositive of 4. Now I'm going to say not S or not L implies R and F. Oh boy. This was L, wasn't it? Yeah, it was L. My mistake. This is De Morgan's law and double negative. 7, if I take negative S or negative L, this is addition. This is using 3 up there. 8, R and F, this is modius ponens, this is using 6 and 7. So if you look at that, not S and not L implies R and F, not S or F happened, therefore the then part must happen, and 9, R and F will yield an F. This is simplification, and this is using just 8. So if you look at the simplification on 8, you could match those. It says P or Q, therefore P. P or Q, therefore P. And that's pretty much it for this section.